Hello students, very good afternoon to one and all. In today's session, we are going to discuss a beautiful data structure, that is the Q data structure. Here we are going to study the algorithms, the two beautiful algorithms called as Enqueue and Dequeue. Enqueue means insert an element into Q data structure. Dequeue means to delete an item from the Q data structure. There you can see the two beautiful algorithms. This is what the Enqueue algorithm and this is what the Dequeue algorithm. That is to delete an item from the Q data structure. Before going to explain these two, Enqueue and as well as Dequeue, let me tell you what exactly the Q stands for. What do you mean by Q data structure? Before that, we have discussed about the stack data structure and two beautiful algorithms called as push and pop. Okay. So here, what do you mean by Q data structure is the most important. Q is an ordered collection of items. Q is an ordered collection of items in which items are inserted and deleted from different ends. I'll repeat the definition once again from the beginning. Q is an ordered collection of items in which items are inserted and deleted from different ends. That is, insertion takes place from rear end and deletion takes place from front end. Here in this Q data structure, we'll be having two separate ends. Insertion is from one end and deletion is from another end. But whereas in the stack data structure, we'll be having only one beautiful end. That end is called as a top end. Insertion and deletions are performed from the same end. So now just have a look at this. Definition is over. Let me draw an array. Simple Q data structure. This is what a simple Q data structure. So this is Q of 0, this is Q of 1, and this is Q of 2, and this is Q of 3. Okay, well you can see here, this is an empty Q. Nothing is stored in this data structure, Q data structure, where you can have Q of 0, Q of 1, Q of 2, and Q of 3. So there are two different ends you can see here. This end I will call it as a rear end, and this end I will call it as a front end. Let me mark those two positions. This is called as a rear and this is called as a front. Just now I said insertion takes place from the which end? Rear end, and deletion takes place from the front end. But in the stack data structure, we were having only one beautiful end. That end is called as a top end. Through that end, we used to insert and as well as delete. Okay, from the same end, we were inserting the elements and we were removing the elements in stack data structure. But in the Q data structure, insertion is from one end and deletion is from another end. Now, just have a look at this Q data structure, which can store a maximum of how many elements? Which can store maximum of 4 elements. Let me write the number. That means the 4 different values which is given by the user, that will be stored in this order. First Q of 0, then Q of 1, then Q of 2, and at the end Q of 3. N minus 1, 0 to N minus 1. N is 4. 4 minus 1 is 3. 0, 1, 2, and at the end 3. The most important part in the Q data structure is initially the Q data structure is empty. Have a look at this. Initially the Q data structure is empty. At that time, the value of front and rear, I'll repeat once again. Initially, when the Q data structure is empty, the value of front and value of rear, where you can see the positions front and as well as rear. There you can see front is the front and rear will be pointing to -1. This is the most important point. Let me repeat once again. When the Q data structure is initially empty, now it is empty. Have a look at once. There are no elements into this Q data structure. Front is equal to -1 and rear is equal to -1. That indicates, that condition indicates Q is empty. That indicates Q is empty. Front is equal to -1, rear is equals to -1 that means Q is empty or else Q is underflow. The second condition, say for example, we have an element 10, 20, 30, 40 or in increasing order or decreasing order or maybe a random order. The elements may be in any fashion. Assume that we have stored 4 different elements, 22, 33, 44 and 55. 22 is stored in queue of 0, 33 is stored in queue of 1, 44 is stored in queue of 2 and 55 is stored in queue of 3. 4 elements were stored in the queue data structure. Do we have any space to add one more item? No. It is not possible to add because already we have stored 4 elements. Let us assume 22 is stored in queue of 0, 33, 44 and 55. Is it possible to add one more item into the existing queue data structure? It is not possible. At that time, the condition will be front is equals to 0 and rear is equals to n minus 1. I'll repeat once again. When the queue data structure is full, the value of front is 0 and the value of rear is n minus 1. This condition indicates that queue is full, or else you can call it as an overflow. The two conditions, the beautiful conditions. During the process of inserting, when the queue is initially empty, at that time front is -1, rear is -1. When the queue is full, front is 0, rear is n minus 1. That means at queue is full. These are the two primary conditions which are associated with the queue data structure. You need to concentrate these two conditions, the most important. Before going to explain this, see, queue data structures are classified into, before that, this queue data structure follows the principle of FIFO. Let me write that one. FIFO. Can you see this one? FIFO stands for first in, first out. This queue data structure follows the principle of FIFO. Stands for first in, first out. But whereas stack data structure that follows the principle of LIFO. LIFO stands for last in, first out. Last in, first out. But here it's a FIFO. There are so many live examples in day-to-day life. The bank is the best example, or reservation counters, the bank. When we enter into the bank, inside the bank, which may be for some transaction purpose, we will go for a bank. Maybe a deposit, or maybe a withdrawal, or maybe a transfer, or maybe to get the demand draft, or maybe to get and open an account. There are so many transactions were involved in the banking sectors. Once we enter, there you will have a cash counters. There are a lot of queue will be there. Assume that some 4 to 5 members are standing in a queue. So 4 members are present. So if I go and stand, I will be the 5th one. So I have to wait for those 4 members should complete their transaction. Then I will go and stand in a nearby the cash counter. The person who is standing nearer to the counter, he will come first. That is why first in, first out. This queue data structure follows the principle of FIFO. You need to remember the name, that is FIFO. Stands for first in, first out, right? So some of the then classifications of queues. There are 4 different types of a queue data structure. First one, simple queue. Second one, circular queue. Third one, priority queue. And fourth one, double-ended queue, or you can call it as a Dequeue. Let me repeat those 4 names once again. Queues are classified into 4 different categories, 4 different types. The first one, simple queue, that is what you are seeing. This is what the simple queue which we have drawn, an empty queue. This can be given an example for a simple queue. Simple queue, circular queue. Circular means in a round fashion. Priority, based on the priority, it is going to execute. And the fourth one is Dequeue, stands for double-ended queue. That means from the same end you can perform insertion as well as deletion. From the same end you can perform insertion as well as deletion. In which queue? Dequeue. These are the 4 different types of queues. Moving to the next segment, what are the different operations which are performed on queue data structure? The different operations, let me tell you the 5 different operations on queue data structure. The first one is a queue function. Queue function. Function means open parenthesis and a close parenthesis. This function creates an empty queue. Queue function creates an empty queue. That is what we have created here. This is a queue. Does it contain any elements? Not at all. This is an empty queue data structure. Nothing is there, nothing is stored in this queue data structure. Queue function creates an empty queue. That creates an empty queue data structure. Second one, the second operations which can be performed on the queue is Enqueue of item. That is what? There you can see the name. What is this? Enqueue of item. Enqueue of item. Enqueue means insert. Enqueue of item. What we are using inside the parenthesis, we are making use of an argument. We are passing in parameters. But in the queue function, we were not at all passing any parameters. But in the second one, that is in the enqueue of item, we are passing an argument or parameters. As you all are aware of the argument, what do you mean by argument and what do you mean by parameter? That and all we have discussed in the last year in the chapter called as a function, user defined function. So enqueue of item that adds a new item into the queue data structure. Enqueue of item that adds a new data item into the queue data structure. The first one, queue function. Second one, enqueue of item. We are passing an argument. Well, moving to the third one, Dequeue. It does not require any arguments or parameters. Dequeue means you can delete an item from the queue data structure. Enqueue means to insert an item into the queue data structure. Dequeue means to delete an item from the queue data structure. Got it? Queue function, enqueue of item, Dequeue. Then comes is empty. This function tests whether the queue data structure is empty or not. Is empty is a function. That function tests whether the queue data structure is empty or not. Moving to the last one, that is the fifth operations which can be performed on queue data structure is size function. Yes, size, that is size function. That function returns number of items into the queue data structure. The size function returns number of items into the queue data structures. These are the operations which are possible on queue data structure. Before that, we have discussed about the types of queue data structure, the definition of a queue data structure, along with some real life example like banking, like reservation counters, right? Now, What I will do is, I'll just move on to the algorithm section. First, I'm going to explain this beautiful algorithm that is called as an Enqueue algorithm. Then I will move on to the Dequeue algorithm. We'll consider this empty queue data structure. Maximum elements which can store in this queue data structure is hardly 4 elements, not more than that 4. Okay. So, have a look at this Enqueue algorithm. Enqueue algorithm. Have a look at the first statement in the algorithm. Step 1. If open parenthesis rear is equals to n minus 1. Let me tell you 1 minute. When the queue data structure is initially, what I said the values, when the queue data structure is initially empty, now it is initially empty. What is the value of front and what is the value of rear? Front is minus 1, rear is also minus 1. You need to remember these two conditions which I have said earlier in the beginning of the class. Front equal to minus 1, rear equal to minus 1. That indicates that the queue data structure is empty. On the other hand, one more condition, front equal to 0 and rear equal to n minus 1. That indicates queue is full. But look at this diagram. The queue data structure is initially empty, does not contain any elements into this queue data structure. Now what I will write here is front is equals to minus 1 and rear is equals to minus 1. Have a look at the values. Front is equals to minus 1, rear is equals to minus 1. Got it? Why I am writing these two values means because the queue data structure is empty, initially empty. Now, straight away we will check the condition now. If rear is equals to n minus 1, what is the value of n? The value of n is 4, right? So, what is the value of rear? Rear is minus 1. Rear is minus 1. Minus 1 is equals to n minus 1. What is the value of n? 4. 4 minus 1 is 3. Now, I'll substitute the value in this condition. Rear is minus 1. Let me write here in this below this statement. Minus 1 is equals to, what is the value of n? 4. 4 minus 1 is 4 minus 1 is 3. 1 is equal to 3. Have a look at the condition. 1 is equal to 3. Is this condition true? 1 is equal to 3? No. Condition is false. So, suppose if the condition could have becomes true, when the condition becomes true means I am going to execute this print statement and as well as this exit. When the condition is true, but our condition is false. Minus 1 is equal to 3, condition is false, isn't it? So I am going to execute directly step 2 without executing this which is written in a square bracket and this print statement and this exit. I won't execute those 3 statements. Directly I will come to this step 2. So have a look at this step 2. If open parenthesis front is equals to minus 1. What is the value of front? What is the value of front? Minus 1. I am going to substitute here the value as it is as front as minus 1. Minus 1 is equals to minus 1. Have a look at this. Minus 1 is equals to minus 1. Is this condition true or false? Of course it is true. Minus 1 is equal to minus 1. Yes, it is true. The condition is true. Isn't it? When this condition is true, I am going to execute these two set of statements. Have a look at this. Before that, some statement is written within the square bracket. Have a look at this. Check whether Q is empty. Check whether Q is empty. Yes, it is empty. Have a look at this. Q is empty. Now, I am going to execute these two statements because the condition is true. Minus 1 is equal to minus 1. Yes, it is true. When this condition is true, I am going to execute before the else, as you all are familiar with the if else condition. If the condition is true, I am going to execute statement 1. If the condition is false, I am going to execute the statement 2. You might be aware of two-way branching. So front is equals to 0 and rear is equals to 0. what values were initialized before this? Before this, the values were initialized for each point, for these 2 pointers. Front is equal to -1, rear equal to -1. Now, the new updated value will be, 0 and 0. Front is also 0, rear is also 0. Before that, both will point to -1. But now, -1 is equal to -1, the condition is true. Condition true means I am going to execute the before the else. Before the else, I am going to execute these 2 statements. Front equal to 0 and rear equal to 0. So, -0 is replaced by -1. Now, after executing these two statements, we'll move on to the step 3. See, don't ask for this statement, we'll execute this, then this statement will execute in the next case. After inserting one element, the next time I'm going to execute this statement, this rear. So, step 3, Q of rear. Q of rear means, what is the value assigned to rear? 0. That means I call it as a Q of 0. See, Q of rear means, what is the value assigned to rear? Have a look at this. What is the value? 0. That means I can call it as a Q of 0, isn't it? Q of 0 is equals to item. That means, whatever the value which is given by the user, that will be stored in the location called as Q of 0. Let me take you to this Q data structure, this representation of simple Q. Where is Q of 0? Q of 0 is here. This is 0, Q of 1, Q of 2 and Q of 3. Through this end I am inserting an element called as 11. That 11 will go and occupy the position in the Q of 0. That's it. I have inserted an element called as 11. That 11 is stored in the location Q of 0. Followed? Next. After that, have a look at this. They have written some statement in the square bracket. Copy item to the rear position. Whichever the element you want to insert, that element must be copied to the which variable? Item. Copy item to rear position. So we have just inserted a one element. Still I can add how many elements? I can add 3 elements. Right? Next. Step 4 return. Again it goes to beginning. Step 1. Have a look at this. If rear is equals to n minus 1. What was the value for the last time rear? Rear was -1. Now this time rear is 0. Have a look at this. Rear is 0. So I'll just change the value. Instead of -1, I'll go with 0. Rear is equals to n minus 1. What is the value of n? N is 4. 4 minus 1 is 3. 4 minus 1 is 3, right? 0 is equal to 3. 0 is equals to 3. Condition false. 0 is equal to 3. Condition false. Last time -1 is equal to 3. Condition false. 0 is equal to 3. False. You need to observe in this Enqueue algorithm, every time rear goes on increases by +1. Last time it was -1, this time 0, next time 1, next time 2, next time 3. Every time during the process of insertion, rear goes on increases by +1. Now, 0 is equal to 3, condition false means I won't execute this print statement and this exit. Direct I'll go to the step 2. Step 2, have a look at this. Step 2, condition. If front is equals to -1, what is the value of front? 0. What is the condition is -1? 0 is equal to -1. Last time it was -1 is equal to -1. At that time the condition was true. But here this time front is 0, -1. 0 is equal to -1. We are checking the condition. 0 is equal to -1. Condition false. Condition, when the condition is false, I am going to execute after the else part or after the else block. So I will take you to this particular line, which I am marking here. This is visible, right? Right. Rear is equals to rear plus 1. Rear is equals to rear plus 1. What is the value of rear? 0. 0 plus 1. 0 plus 1. 0 plus 1 is 1. Now rear gets increased by plus 1. First it was minus 1, then 0, then 1. So after executing this, I'll go to step 3. Q of rear. Q of rear means Q of 1. Last time Q of 0 and this time Q of 1. Q of 1 is equals to item. Whatever the value which is given by the user, that will be stored in the location called as Q of 1. Last time we have given the value as 11. 11 is stored in the Q of 0. And I am going to give now 19. 19 will be stored in the location called as Q of 1. Right. Again, after that, step 4, return. Again, it goes to the beginning of the algorithm. That is Enqueue algorithm, the beginning. Now, if rear is equal to n minus 1, what is the value of rear? Last time it was 0, now this time 1. 1 is equal to 3. 1 is equal to 3. Condition false. Condition false means I won't execute this print and exit. I'll directly move on to step 2. Step 2 straight away condition here. If front is equals to minus 1, what is the value of front? Front is constant. It remains 0. Front is 0. 0 is equal to minus 1. Condition false. Condition false means it comes after, it executes after the else part. That is rear is equal to rear plus 1. What is the value of rear? 1. 1 plus 1 is 2. 2 is assigned to rear. The next step 3. Q of rear. Q of rear means Q of 2. Q of 2 is equal to item. The third value which is given by the user, that will be stored in the location Q of 2. Say for example, I am going to give the value as 15. 15 is stored in the location Q of 2. Then step 4, return. Again it goes to beginning of the algorithm. Now, step 1, if rear is equal to n minus 1, what is the value of rear? 2. 2 is equal to n minus 1. N is 4. 4 minus 1 is 3. 2 is equal to 3. Condition is false. Right? Condition is false. Check for overflow. The next print overflow. Sorry, these two statements will not be executed because the condition is false. 2 is equal to 3. Condition is false. It comes out and executes step 2. If front is equals to minus 1, what is the value of front? Front is 0. 0 is equals to minus 1. Condition false. Condition false means I am going to execute after the else part. That is rear equal to rear plus 1. What is the value of rear? 2. 2 plus 1 is 3. 3 is assigned to rear. Okay. Then again step 3. Q of rear means Q of 3 is equals to item. The value which is the fourth value which is given by the user, that will be stored in the location called as Q of 3. Say for example, I am giving the element as 13. The elements may be in any order. Okay, which may be an increasing order, decreasing order, or random order. Here I have given the random order. No problem with elements. Okay, these elements. 13 is stored in the Q of third location. See, have a look at this. How many elements are there? 4 elements are there. Now after that, again step 4, return. Again it goes to the beginning of the algorithm. Now comes the interesting part here. Have a look at this. Step 1. Rear is equals to n minus 1. Rear, what is the value of rear? 3. I am going to substitute the value here, 3. 3 is equals to n minus 1. What is the value of n? N is 4. 4 minus 1 is 3. So, have a look at the condition. Just compare the value. 3 is equal to 3. 3 is equal to 3. Of course, it is true. True means I am going to execute this print statement and this exit. Have a look at the statement which is written in the square bracket. Check for overflow. That means the Q data structure is full. You cannot insert a new item. Maximum capacity is 4. That is what we have inserted. 11, 19, 15 and 13. So check for overflow. I am going to display the message as print Q is full or else Q is overflowing. That means there is no space there is no space to insert an item into the queue data structure. After that, exit. It comes out of the algorithm. It comes out of the algorithm. What you need to notice in this Enqueue algorithm is, during the process of insertion, every time rear goes on increases by +1 and front will be 0. When the queue is empty, front and rear will point to -1. You need to remember these two conditions. And when the queue is full, front is equal to 0 and rear is equal to n-1. You must be aware of these two conditions to deal with these two algorithms. This is about the Enqueue algorithm. And now I'll just move on to the second algorithm in this queue data structure, that is a Dequeue. Dequeue means to delete an item from the queue data structure. To delete, what we have done here now is, initially it was empty. Every time we used to insert a new item into this queue data structure. First, initially it was 0, no elements at all. At that time, front is -1, rear is -1. Then, at the during the insertion of first element, that is the 11 is inserted at the first. Then becomes front equal to 0, rear equal to 0. Then we have inserted 19. Then front remains 0, rear goes on, increases by +1. That concept you need to remember. But the same thing will not happen in the deletion. In deletion, rear remains fixed. Front goes on, increases by +1. I'll repeat once again. And during the process of deleting an element from the queue data structure, front remains, front goes on, increases by +1, rear remains constant in a Dequeue algorithm. We'll see how this algorithm works. Okay, I'll go with the same 4 elements. Okay, have a look at this Dequeue algorithm. Step 1, if front is equals to -1, before that you must be aware of front is equal to 0, rear is equals to 3, because we have stored 4 elements. What you can say, queue is full now. Now what I need to do, I need to delete each element every time, each element until the queue gets empty. Okay, so you need to remember these two values. Front is 0, rear is 3. Step 1, if front is equal to -1, what is the value of front? 0. 0 is equal to -1. 0 is equal to -1. Condition false. I am going to write here 0 is equals to -1. Condition is false. Condition false means I won't execute these two statements, that print and exit. These two statements will be executed only when the condition is true, but our condition is false. That is 0 is equal to -1. The condition is false. I will directly move on to step 2. Have a look at this. Item is equals to queue of front. Item is equals to queue of front. Queue of front means what is the value of front? 0. That means queue of 0. What is the value stored in the queue of 0? Have a look at this. What is the value stored in queue of 0? 11. I am targeting that element should be deleted first, because the queue data structure follows the principle of FIFO, stands for first in, first out. I'll repeat once again. The queue data structure follows the principle of FIFO, first in, first out. As I said earlier at the beginning of the class, the best example is bank. The person who is standing nearer to the cash counter, he will comes out first, and the person who is standing last, he will come last. That is nothing but the principle is FIFO, first in, first out. So the 11 I am targeting, that must be deleted. Have a look at the step 2. Item equal to queue of front. Front means 0. Queue of front means queue of 0. What is the value stored in queue of 0? 11.
I am targeting this element. Okay, I am targeting this element. Step 3. If friend is equals to rear, what is the value of friend? 0. And what is the value of rear? 3. 0 is equal to 3. 0 is equal to 3. Condition is false. 0 is not equal to 3. The condition is false. Condition false means I am going to execute after the else. I am going to execute after the else part. That is, friend is equals to friend plus 1. Friend is equal to friend plus 1. So, friend is 0. I am increasing the friend pointer by plus 1. Now, friend becomes 1. Last time it was 0 and this time 1. See, during the process of insertion, rear goes on increases. During the process of deletion, friend goes on increases. This is what the difference. You need to notice these points. Now, friend equal to friend plus 1 means 0 plus 1 is 1. 1 is assigned to friend. Next, that is what we have done just now. Increment the friend pointer. We have just incremented by plus 1. Step 4, return. Again, it goes to step 1. If friend is equal to minus 1, what is the value of friend? 1. 1 is equal to minus 1, condition false. 1 is equal to minus 1, condition false. So condition false means directly it comes to step 2. Item is equals to Q of friend. Item is equals to Q of friend means Q of friend. What is the value of friend? 1. Q of 1. What is the value stored in Q of 1? 19. I am targeting 19 must be deleted. Last time we have targeted for 11. Now this time 19. See, you need to observe how each elements are going to be deleted. First Q of 0, then Q of 1. Next, item equal to Q of friend. Q of friend means Q of 2. The value stored in the Q of 2 is the value stored in not 1 minute. Item equal to Q of friend. Friend is 1. So Q of friend, what is the value stored in Q of friend or Q of 1? That is 19. 19 is assigned to item. That must be deleted. Step 3. If friend is equals to rear, what is the value of friend? 1. And what is the value of rear? 3. 1 is equal to 3. Again, condition false. Condition false means I won't execute these two statements. I will execute after the else block. That is friend equal to friend plus 1. Friend is already we have 1. 1 plus 1 is 2. 2 is assigned to friend. What we have done? We have just incremented the friend pointer. Then step 4, return. Again, I will go with step 1. If friend is equals to minus 1, what is the value of friend? 2. 2 is equals to minus 1. 2 is equal to minus 1. Condition false. 2 is equals to minus 1. Condition false. Condition false means directly comes to step 2. Item equal to Q of friend. Q of friend means Q of 2. What is the value stored in Q of 2? 15. I am targeting for the third element that 15 must be deleted from the Q data structure. So step 3, if friend is equal to rear, what is the value of friend? 2. 2 is equals to 3. 2 is equal to 3. Condition false. 2 is not equal to 3. Yes, it is true. 2 is not equal to 3. Condition false. Condition false means I am going to execute after the else block. That is friend equal to friend plus 1. So what is the value of friend? 2. 2 plus 1 is 3. 3 is assigned to friend. Next, increment the friend pointer. Just now we have incremented step 4, return. Again it comes here step 1. If friend is equals to minus 1, friend is, what is the value of friend? 3. 3 is equals to minus 1. 3 is equal to minus 1. Condition false. Condition false means I won't execute this print statement and exit. I'll directly comes to step 2. Item equal to Q of friend. Item is equal to Q of friend. Q of friend means Q of 3. What is the value stored in Q of 3? That is 13. What I am doing is I am targeting for the fourth element. Fourth element, that is 13, must be deleted from the Q data structure. And the step 3, this is the most important. Step 3, if friend is equals to rear, have a look at the values. Friend is 3 and rear is 3. Have a look at the value once again. Friend is 3, rear is 3. I am going to substitute here. 3 is equals to 3. 3 is equal to 3. Yes, it is true. Well, this condition is true means I am going to execute before the else, not after the else. I am going to execute before the else. Before the else means I am going to execute these two values, these two statements. That is front equal to -1, rear equal to -1. So I will change these two values. Front remains -1 and rear remains a -1. After that, step 4, return. Again, I will go with the step 1. If front is equals to -1, what is the value of front? Have a look at the values. What is the value of front? Front is -1. So -1 is equals to -1. Have a look at the condition in the beginning. -1 is equal to -1. Condition true. -1 is equals to -1. Condition true. When this condition is true, I supposed to execute this print statement and as well as exit. Print, what I am printing a message? Underflow, or else you can print the message as queue is empty. Queue is empty or else underflow. Both are same. Underflow and immediately exit. I will come out of the algorithm. This is, have a look at this. Do you have any elements in this queue data structure? No. Initially this queue data structure is full. Okay, what we have done, we have just deleted one by one elements. During the process of deletion, you need to observe, during the process of deletion, rear remains fixed. Front goes on increases by +1. In which algorithm? In Dequeue algorithm. But in the Enqueue algorithm, during the process of insertion, front remains constant. During the process of insertion, front remains constant and rear goes on increases. In insertion, rear increases. In deletion, front increases. This you need to remember. And along with the two beautiful conditions, let me remind you once again. The first one, when queue is empty, at that time front is -1, rear is -1. That is what we are displaying now. Initially the queue is empty. What is the value of front? -1. And what is the value of rear? -1. The second condition, when the queue is full, front is 0, rear is n-1. This condition indicates that queue is full. I'll repeat once again. Front is 0, rear is n-1. This indicates queue is full. You cannot insert more elements into the existing queue data structure. These are the two primary conditions one has to follow with this Enqueue and as well as a Dequeue algorithms. Okay, let me repeat the definition once again. A quick remind. Queue is an ordered collection of items in which items are inserted and deleted from different ends. Queue is an ordered collection of items in which items are inserted and deleted from different ends, where insertion takes place from the rear end and deletion takes place from the front end. The queue data structure follows the principle of LIFO, stands for FIFO. Queue data structure follows the principle of FIFO, F-I-F-O. F-I-F-O stands for first in, first out. The best example is a banking example, banking or any railway reservation, any reservation counters where we used to stand in a queue. The person who is standing very near to the counter will comes out, and the person who is standing very last, he will come last. Okay, those are all the real-time example for the queue data structure. Some of the applications of queue data structures are, I just mentioned hardly some 2 to 3. Print server routines, simulations, scheduling algorithms, round-robin algorithm, multi-programming platform systems. Okay, these are all the applications of queues, right? These two algorithms are the most important. Okay, thank you for watching this video.